Hello everyone, my name is Udifa. I am in the first year of the university. In this video we are going to see how we can crop the image. For example, in our Sudoku grids we need to crop the image into 81 cells. Now if you haven't seen my first video where I showed the whole project yet, feel free to have a look at it. The description is below in the description. Now if you're ready for this, let's jump to the computer and let's get started. So here we are, it is always the same notebook as we worked last time. The only change is there. So we are going to see through this, but first I'm just going to go through this because this is very important to understand. So here we create a new image named cell, which is the top left of a Sudoku grid. And here we have image corner. So do you remember? Image corner is the image that we used to turn in binary in the last video. We have 0 to 10, 0 to 10. So what do I mean by that? So first of all, let's see how the coordinates in the image work. So always the starting point is, the origin is always in the top left corner. So as you go along this axis, this is the x and this is the y. So normally in a graph you should put the y above it, and this is the negative, but this is not the case. Here we are going to 900 in the height, and here we are going to do the 900 in the width. So do you remember the image is 900 pixel by 900 pixel. Okay, so we say that it is 0 to 100 and 0 to 100. So now this notation is a little bit tricky because that is starting with the height and that is the width. So if you say the height is 0 to 100, that means that you're just taking the height from 0 to the height of 100, which is a cell, because 900 divided by 9, the number of cells in the column, is 100. So we are gonna have 0 to 100, and the same with the width, we will have 0 to 100. So in fact, we will end up here, which is cover the first cell. So now let's print it to see how it looks. So here to display the cells, I'm not gonna use OpenCV2 IamShow because as you can remember, this creates a new window and we don't want that. We don't want to create 81 window that will completely be a big mess. We want to print them in the console like a print statement. So we use PLT, and to have that you must import this library. Import matplotlib.pyplots as PLT. So, and then this is how we display it. You just write PLT IamShow cell, because it is the name of the image, comma, cmap equals to gray. So this function here is used to transform the image into a grayscale. So you are probably thinking, why do I need to turn a binary image into grayscale? Well, the problem is that library, when it's grayscale, it tries to colorize itself, and I tried that, and in fact it puts a yellow background instead of white and kind of purple digits instead of black. So so always, even if you work in a binary image, grayscale image or whatever, if you want to keep it grayscale or binary, just put cmap equals to gray inside quotes. And then we got plt.show. So that is just to print. Every time you put IamShow, you need to have a show below. So now let's restart it and run. Yeah, as you can see, it has printed the one, which is the first cell in my example. So I hope that was very clear. So now we are going to see through these loops. So this is the most interesting part of this video. So this loop in fact prints all the image, all the individual cells in the Sudoku grid. So we are going to see how it works. So image corners, I just crop the y value. So first of all, it will be 1. So 1 by 100 minus 100 is 0. And 1 times 100 is 100. So it will start with 0, 100. And same with x. We have x times 100 minus 100, which is if it's 1, it's 0. If it's 9, it will be 800. And x times 100, if x is 9, it will be 900. So that is so sometimes it is a good idea to think how can the value affect this if you don't want to have compiler errors. So here I just imagine that the last one must be something like 800 to 900, and it actually does. It's the same for the one, for the first value of y or x, whatever. It starts with 0 to 100. So now let's comment this and run this to see what happens. Yes, so that is actually working. So the first value it's 1, but the problem in this one is that it reads column by column instead of lines by lines. As you can see in this image, we have one empty 4 and one empty 3 on the column, and this is what we have. We have one empty 3. So it reads like this. Like this column first, then this one, then this one, then this one. So it won't actually make matter, but if you want to personalize this, we can make it read line by line. That would be easier. So let's do this. So we just need to inverse the y and the x in the loops. And here I think, yes, here we got a better result. So I'm just waiting for the binary image to show. Yeah, let's hide this. Yeah, so as I said earlier, one empty 4. That's what we got. We got one empty cell 4. Then we should have 3 empty cells. Yes, we get that. We got also a 7. Then we should have a 5. Yeah, so that is following the thing. But the problem is that, you see, we can still see the borders of the cells. So we want to get rid of that. So we will try to crop it more. So for that, just create a variable. Let's say crop value equals to, let's say 20. And here I'm going to add the crop value. And here I'm just going to take away the crop value. So instead of dividing the image, it will take a little bit to the center for each cells. Let's add it. Let's take away this. So honestly, this isn't the result as I expected, because the empty cells are in black and they should be in white, but it doesn't matter. It will be it will still be detectable. So we got the one, and we see that we don't get any contours. Same for same for everything. Yep. So thank you for watching my video. So now we can crop the image. Next time we're going to see how we can save them in the computer, and how we can transfer them, and how we can change them, because in deep learning we are going to add to we are going to we need a lot of data, at least thousands of them. But don't worry, that should be very easy. We just need to make sure that the numbers are not so different, because sometimes we get like that are nearly erased in, and sometimes we have. Oh, mais qu'est-ce que je chie là? So that was it for today. Thank you for watching my video. Now we can crop the image. Next time we are going to see how we can save them in your computer, and also how to modify them, how to make a data augmentation. So a data augmentation is in fact something to create new image that are very similar to the one that we will save them, and we will create a lot of them. Because sometimes, as you can see, some of them are very thin, and for the deep learning it will be very difficult to learn that, because that will look so different numbers, and we will try to make it a big data augmentation. So thank you again for watching this. Don't forget to subscribe and activate the notifications, and like this video if you enjoyed, and see you next time.